Hello students. Today we are going to discuss about refraction of light at curved surfaces, class 10, lesson 4. Right? So we learned already about refraction of light. Right? At plane surfaces. In ninth class we studied about this one, right? So what is refraction? Refraction is bending of light, right? It's a process of bending of light. So it's a bending of light, right? Bending of light when it passes from one medium to another, right? One medium to another. What happens here? Density of the medium changes, right? At that time, light choose the shortest path to travel. So here, what I am taking, air and water, two different mediums we are having here, air and medium. Okay, so this one we know. If you drop a pencil in glass of water, here it is half filled water. What will happen when you drop a pencil in this? You will see that it is somewhat bending, right? So why we are seeing this bending, right? So see, uh, when light ray is passing from air to water, right? Air to water. What happens here? I am drawing normal. Normal is the imaginary line. It's an imaginary line, right? Which makes 90 degrees with the separating line. So it is a separating line which is separating water and air, right? So for this line I am drawing normal, right? It is normal, right? Suppose here, see, any light coming from air to medium means light is passing from rarer medium to denser medium. Rarer medium to denser medium. What happens here? Actually it should go like this, right? It should go on like this, but it is not going. So it is bending towards the normal, right? When light ray travels from denser medium to rarer medium. Denser medium is water, rarer medium is air. So when it is traveling from, suppose it should go on like this, but it will refract like this, right? So it is this is the shortest path for this light ray to travel. That's what it is traveling. This phenomena is called refraction of light. When any light ray is passing from rarer medium to denser medium, it bends towards the normal. When a light ray is passing from denser medium to rarer medium, it bends away from the normal, right? This is universal law related to the refraction of light. Okay, right. Next, here in this lesson we are going to study about refraction of light at curved surfaces, right? Curved surfaces. What we are considering here, we are taking glass, uh, transparent medium which is made up of glass. Okay, again it is having one side curved, other side also curved means, or it may have, this is bulged surface, right? It is curved surface, curved inside, curved outside. Clear? So these type of uh, mm, objects are taken as curved surfaces, right? Next we have a lens. Lens. What is lens? Lens is formed when a transparent when a transparent transparent material is bounded by bounded by two surfaces two surfaces. which one or both are spherical. Bounded by two surfaces, it may be spherical in shape. Right? Lens is formed when a transparent material is bounded by two surfaces of which one or both are both are spherical. Both are spherical. Okay. Right. See here. So this is definition for lens. Lens is formed when a transparent material is bounded by two surfaces of which one or both are spherical. From where we are getting these spherical uh, transparent material? Suppose I am having a spear shaped glass ball, right? If I am taking one part of this, what I will get? Like this, right? One more spherical sphere is there. From that, one more second part is taken like this. It is bounded by together. So what you will get finally? A lens in this form, right? Both the sides are convex, right? Right. So it is biconvex lens. It is biconvex lens, right? Suppose if you are taking uh, lens of both the sides having curved inside, that is called biconcave lens. Biconcave lens, right? Biconvex lens, biconcave lens. Then if one side is plain and other side is concave, like this, I'll take, this is not there, right? Right, it is from left to right. You have to play left side, we have plano concave lens, it is. Okay. Suppose you are having plane surface with the concave on other side, right? What type of lens it is? Plano convex lens. Convex lens. Okay. Next, suppose here you have concave side and other side is convex. It is concavo. This side we have concave. It is this side we have convex. It is concavo convex lens, right? Suppose if you are having this side left side bulged surface and you are having curved side inside, it is convexo concave. Convexo concave, right? These are the six different types of lenses are available. Biconvex lens, both the sides are bulged, it is biconvex. It is biconcave. Plano concave, plano convex. Concavo convex, convexo concave, right? These are the different types of lenses. Okay. Right. Generally where we use these lenses, right? These are used in making of spectacles, making in used in microscope, right? Okay. Next, we have ray diagrams to draw. Before that starting, so every time here we are going to draw ray diagrams for biconvex lens, right? Convex lens. So while drawing ray diagrams, we'll not use this symbol. Instead of using this, we use this symbol. Okay. It represents biconvex. This symbol represents concave. How to remember this one? Simply if you extend these ends, you will get concave lens, right? If you extend like this, is it resembling your convex lens, right? Yes. And if you are having two concave lenses together, you will get this picture. So this is logic to remember. Convex lens, convex, concave lens, biconcave lens, biconvex lens, short form. Okay. Right. Before going to here we have one definition of her optic center. Optic center, we know the remaining terms: focal length, center of curvature, all are same like your concave mirror and convex mirror. There we have pole, in the place of pole we have optic center, right? The midpoint of the lens is called optic center. The midpoint of lens is called optic center. Clear? Right. First we will draw our ray diagrams. When object is, so we are using for convex, we are drawing ray diagrams for convex lens only. So use this symbol to represent your convex lens, right? Right side you take F1, C1 and F2, C2 on left side. Why we are having two F1, C1 means it is bounded, uh, it is biconvex lens, right? So we are getting two plano convex, right? Here I am having one plane convex, right? These two are bounded by each other. This may have different focal length and center of curvature. This lens may have different focal length and center of curvature, right? So we are using that only here. Okay. Again, there is a relation between F1 and C1. What is F1 and C1 relation? C and F relation is F equals to, sorry, C equals to 2F. Suppose your center of curvature value is 6. F value should be 3 only, right? Or F equals to C by 2. C by 2. Your F center of curvature is 6 means what is your focal length? 3. Okay. Here I am taking 2.5 centimeters and distance between optic center and C is 5 centimeters. Right? Here also I am taking same 2.5 and 5 centimeters. Both the sides I am taking same. Right? So when parallel, object is at infinity. Object is at infinity. Right? When object is located at infinity, all the light rays are coming from the object is in parallel to the principal axis. Right? Where they meet, any light ray passing through the convex lens refracts through the focus. Refracts through the focus. Right? This is similar as our ray diagrams what we discussed in lesson 1. Right? So before going to that, we will go through our rules first. What is our rule 1? First rule: any light ray passing parallel to the principal axis refracts through focus. This is our first rule: any light ray passing parallel to the principal axis. Right? Next, any light ray passing through the optic center will not deviate. This is our second rule we are following here. These are the rules two. First one, second one. Mostly we use these two rules only. Okay, any light ray passing parallel to the principal axis refracts through focus. Any light ray passing through optic center will not deviate. Okay, right here first rule only applicable. All the light rays are parallel to the principal axis. They refract through the focus. So where we are getting image at F, right? This is the image of sun. Okay, here if you place screen, then only you will get image. Right? Nature of image you have to write as we discussed in first lesson. Every time you have to write nature, it is diminished and inverted. Inverted image you will get always. It's real. So we are getting image on screen, right? It's real image on F. Location is on F. Clear? These are the nature of the image or characteristics of the image. Okay? Right. Second one, when object is beyond C. Beyond C. Okay? beyond C. First, represent your convex lens using the symbol. Draw a principal axis 2.5 centimeters, 5 centimeters. Here also 2.5 centimeters, 5 centimeters distance from optic center. Right? So, where we placed our object beyond C. Right, my object is beyond C. I am taking this 1.5, you also take 1.5 centimeter, approximately it is 1.2. Okay, now what is our first rule? Any light ray passing parallel to the principal axis refracts through focus, right? Same, use scale while you drawing, I am not using here. Right, it is parallel to the principal axis, right? Refracts through the focus. Clear? Right. Second rule, any light ray passing through the optic center will not deviate. This is our optic center, right? So, like this. Use scale while you drawing. So, that is here they are intersecting. It is not correct. So, it is intersection point, right? So, any light, first light ray passing parallel to the principal axis refracts through focus. Second, right, second light ray passing through the optic center will not deviate. It go in a straight line. Okay. So, nature of the image, nature of image. You write completely. First one, enlarged or diminished. Here we got somewhat diminished, so it is diminished. Diminished means size of the object decreases. Here it is somewhat 1.5. Here I got only 1 centimeter height. So size is decreased. So it is diminished. So if I place screen only, I'll capture the image. So it is real. And we get reverse image. So that is inverted. Inverted will image I'll get. So where I'll get the image between F and C. This These are the nature of the characters, right? Next one, when third case finished, right? Fourth one, when object is placed between F and C. Object is between F and C, right? F and C. So I'm drawing principal axis F1, C1, F2, C2. Right? Object is between F1 and C1. First rule, any light ray passing parallel to the principal axis refracts through focus. Right? Any light ray passing through the optic center right, this is my intersecting point. Okay, nature of the image, enlarged, right, it is real image, and inverted and beyond C. See, right? So what we discussed here is completely went wrong. Okay, we'll discuss this situation here. So when object is third case, right? Object is at C, right? So place here convex lens F1, C1, F2, C2. Object is on C, right? So first case in my got correct. So refracts through focus. Any light ray passing. Any light ray passing. Yeah, I got. This is correct. Right? So nature of the image. So here little bit I got wrong. Still it is same as object height. It is not enlarged, not diminished. Object height. Next, real, inverted. Okay, and at C only we'll get. These are the characteristics of the image when object is placed on C. Right? Next one, fifth case, object is between P and F. Optic center. Object is between P and F. Okay, optic center and focus. Right? This is little bit different. F1, F1, C1, F2, C2. Object is here. Any light ray passing parallel to the principal axis refracts through focus. Any light ray passing through the optic center will not deviate. So these two rays will not meet anywhere, right? These two rays will not meet. So these two are looking as diverging rays, right? They are diverging rays only. Now what I am doing, I am extending my lens backside. Extend your lens backside like this. Okay. Here I am getting like this. So here we'll get image on the lens itself now in this case, right? This is object, here it is image. You may get confused, right? Nature of the image, nature of the image, what you will get here, uh, it is enlarged, right? Enlarged. And real or virtual, it is virtual, virtual. And it is erect, straight only we are getting, we are not getting inverted, right? Erect image, virtual image, enlarged image. And where we are getting, behind the lens, on the lens. So I am using the word on the lens. So this is very useful case, preparing microscope, right? When object is between P and F, we will get the enlarged image. Okay, so microscope works on this principle only. We'll see the image on the lens only, right? Next one, we forgot one case, last sixth one. Object is on F, on F. Okay, right. When object is on F, draw a convex lens, F1, C1, F2, C2. Right? Object is on F. Any light ray passing parallel to the principal axis refracts through focus. Any light ray passing through the center, optic center will not deviate. See these two lines. These two lines are parallel to each other. They cannot meet at anywhere. So we cannot, nature of the image, nature, we cannot, we cannot decide the nature of image. Okay, nature of the image. Right, next topic. Moving to next topic. Suppose if you have a convex lens, right? Again F1, C1, F2, C2. Right? One light ray is coming in this direction. How it refracts? It's completely different. Object is not given, only light ray is given, right? So in this situation, we have to follow some steps how it is refracting, right? So first, extend your light ray. So I am drawing my lines also like this. I am extending my light ray where it hit the lens, right? So for to this light ray, I want a principal axis, new principal axis, which is passing through the optic center, right? First, extend your or draw a new principal axis which is parallel to the light ray. Reverse we are going. In previous case, we are drawing a parallel light ray, right? Here only light ray is given. So first what you have to do, extend your principal axis which is parallel to the light ray. So see this. So place your scale for this. Is it parallel or not? Yes. So this is my new principal axis. Extend your focus using dotted lines. This is my new focus where it is touching. Okay. Now what is my rule 1? Any light ray parallel to the principal axis refracts through focus. Okay. So how it light ray passes in this way after crossing this lens, right? Next case, for concave mirror we'll draw this type. Most of the time we'll get this type of questions only. This type of questions, they'll give any light ray which is not parallel to the principal axis. For that what you have to do, first step, draw your new principal axis which is parallel to the light ray. This is your light ray. For this line I am drawing one parallel line, right? I am extending my through focus I am drawing one dotted line. So where these two are meeting, that is my new focus. Through this focus light ray is refracting. Got? Right. Next, for concave mirror, by concave mirror we are drawing a we ray diagram. Okay, object is placed here. That same rule you have to follow. Any light ray passing through the parallel to the principal axis, right? It is a diverging mirror, right? Here biconcave is a diverging mirror. It diverges the light. So how it is diverging? Extend your line to the join these two line using dotted line, and this is your diverging line, right? So it is going in this way, right? Next, any light ray passing through the optic center will not deviate. So where these two are meeting here. Here I am getting the image. What is the nature of the image? Diminished. Is it useful for us? No. Diminished we are getting, right? Even though it is erect, it is not useful for erect. For us, it is erect image and diminished, and it is virtual image. Next, on the lens, we will get the image on the lens. So it is not useful to enlarge the images. So whatever it is there, it is we are able to see the diminished image. Only we have one ray diagram for biconcave lens, right? Next, suppose if you are having a concave lens, okay, suppose here we have a light ray which is uh, going in this way, light, this is going in this way. So how it diverges? We have to draw ray diagram for this biconcave lens. So first I am extending my lens where it is hitting. So light ray will go in this way, right? So this is not parallel to the principal axis. I am changing principal axis which is parallel to this line. This line is parallel. These two are parallel, right? Now I am extending my, not this one, focus. Left side focus you have to extend. Right, where this is meeting here, right? So how it diverges? Now join these two lines and it go like this. These are the, so it diverges like this. So this, well, first draw a principal axis which is parallel to the light ray. Extend your dotted focus, right? Where it is intersecting this line, principal axis and focus, that is your new focus. So this line diverges through focus, right? So here we will get like this. Okay. These are the ray diagrams related to the convex lens and concave lens. Clear? Right. Next, we have mirror formula, that is sorry, lens formula. It is lens formula. As we have mirror formula in first lesson, what is that? 1 by f equals to 1 by v minus 1 by u is our lens formula, right? Next here, lens makers formula. Lens makers formula, that is 1 by f 1 by f n minus 1 into 1 by r1 minus 1 by r2. Okay, right. What is f? Focal length. And n is refractive index of the lens. Refractive index of lens. Okay, next r1 and r2 are radius of curvature. Radius of curvature. Every lens here we will have two radius of curvature, sir. That only we are taking here. What we are discussing, curvature of lens, we are using no C1, C2, that is equal to R1 and R2 curvature, right? Radius of curvature R1 and R2. Okay. Here we have one problem related to find what is the focal length of the double concave lens. Right. Here in this question, R1 and R1 is given as minus 30, R2 given as 60. It is page number 82, that question. And refractive index given as 1.5. So they are asking to find 1 by f. What is our question? We will read. What is the focal length of the double concave lens kept in air with two spherical surfaces of radii? R1 equals to 30 centimeters, R2 equals to 60 centimeters. Take refractive index of lens as n equals to 1.5 centimeters, right? So information what is there in the question I wrote. So they're asking to find f. 1 by f equals to 1 by v minus 1 by u, right? Sorry, lens makers formula, no? 1 by f equals to n minus 1 into 1 by r1 minus 1 by r2, right? So substitute the values. 1.5 minus 1, right? So 1 by r1 how much? Minus 30 I'm writing here, again minus 60. Here you will get 2 by 60 minus 2 minus 1 by 60. Find the LCM here. 60 will get. So if I convert here denominators, 60 will get here, 2 will get. So 1.5 minus 1 how much? It is 1. And minus 2 minus 1 how much? So 1 into minus 3 by 60. So what it is? 1 by f. F equals to, I am reversing the values. 1 by f equals to minus 3 by 60. If we will do cancellation. 1, 3 ones, 3 20s. Right? One 1.5 minus 1, it is 0.5. So it is 0.5 into 1 by 20. 1 by f equals to, right? 1 by f equals to 0.5 into 1 by 20. For 0.5 I am writing it as 5 by 10. So I am removing decimal point. In the place of decimal point 1, how many digits are there? That means zeros we have, right? And 1 by 20. Clear? Cancellation. 4 1 by 40. 1 by f equals to 1 by 40. So f equals to 40 centimeters. Focal length of the lens is 40 centimeters here. Okay, this is your problem. Right. Here we have one more lab activity related to lens is In page number 75, observing the types of images and measuring the object distance and image distances from the lens. Right? So, here we have one lab activity. Take a V stand as of your first lesson. There we are keep placing one mirror, right? Here we are using convex. It is convex lens. Okay, right. For this convex lens, I am placing scale on a paper. I am drawing scale. So here I am 0. Okay, values are written on the scale. So if you place your object, okay, where you will get the image? Right side you will get. Here you have to place your screen. Right. Now you have to move the object in you have to place your object in different places, and where you are getting, you have to write your observations. When it is beyond C, where you are getting the image. When it is on C, where you are getting the image. Right. So as a of your first lesson, what we learned there, that is our lab activity. Little bit changes. So here, left side we are placing our object, right side we are used to get the images, right? So that is our lab activity. Okay. Next, last topic. So with this lesson is completed. Thank you.